Hello and welcome back to another sweltering episode of Artisan Electrics. It's 30 degrees outside and I'm stuck in this flat which is very well insulated. It's baking hot and I am doing EICR. It's quite a new flat, this one, so I'll show you around. It was built in 2012, so hopefully everything's going to be okay, but we'll see. You never know with new builds. It's kind of a luxury flat really, it's quite nice. It's got a lovely kind of balcony and beautiful view outside and stuff. It's a furnished one and the tenant's literally moving in tomorrow, hence why I need to do this quickly. We've got mains powered smoke alarms. They must have 2 years life left in them still, I guess, so we'll probably leave those for the moment. Halogen downlights here in the kitchen, but the downlights here are those really horrible compact fluorescent ones that take forever to warm up, which is a little bit annoying, but not the kind of thing that I'm going to code, obviously. Looks like a bulb's blown there. Kitchen, we've got a bank of switches there. It's quite interesting actually. It's a bank of switches with fuses in, so looks like it's kind of been siliconed in. Somebody's obviously taken it off. This neon is a little bit blown. You've got 3 fuses, so it looks like the oven circuit is separate, and then you've got fridge, freezer, dishwasher and cooker hood. We've got a cooker switch here as well, presumably that's for the hob. So turn that on, and then if I turn that off, yeah, so that's for the hob. Oven. Sorry if I'm not very enthusiastic, I'm just so hot. It's 31 in here. So we've got a bathroom. Again, it looks like halogen downlights in here. Can't believe, 2012, it seems quite recent that, it's like I'm sure we weren't fitting halogen downlights in 2012, but apparently we were. Yeah, look at that, 31 degrees. So, just these horrible compact fluorescent downlights there, and this one's on its own switch. Yeah, I mean, it's a very small little flat. They've got MK double sockets dotted around the place. Nice amount of sockets, but I'll show you the consumer unit, and then before we take the cover off, we'll do the guessing game with new builds of whether it's been done nicely or not. So this is the consumer unit, and looks fairly decent. As we can see there, the original inspection was done in 2012, so presumably that's when it was first built. Smoke alarms fitted at the same time. And here are the circuits. Now everything's nicely numbered, which is good. And then, amazingly, we've got a circuit schedule here. So that makes it really, makes my life a lot easier when it comes to actually knowing what does what. That saves a lot of time, which is great. So I can just take a photo of that and copy the details onto my circuit schedule. Interestingly, there's a little contactor here at the end. Not quite sure what that does, so that's going to be interesting to find out. But let's whip the cover off and we'll see what's inside. So a little lesson just to show you, for you learners here, something that's important to do is when you're going to turn the power off, obviously it's best to turn everything off before you take the cover off. But rather than just turning the main switch off and leaving all the circuit breakers on, the safest and best way to do it is to turn the circuit breakers off first. And then turn the main switch off. Then you're not switching it off with load. So it's just a little tip, and someone highlighted in one of my videos the other day that I don't think I did it the right way around or something. Sometimes you're just kind of in automatic pilot. And so here, this is the side of the main RCCB, and can you see that it's cracked? The plastic is actually cracked open, and if I get my little pliers in there, that will probably just come out. Yeah, there we go. Not great, that. How on earth did that happen? You know what I guess might have happened? I'm not sure actually. It might be, I was thinking that someone might have got a screwdriver like that and just tried to line the breakers up and just pushed in the side of it, and they've cracked it. But that's a difficult one really, because there's only live parts accessible when the cover's off, but it's still, you know, it is broken, so it's not up to what it was designed to do. Interesting. Let me know in the comments how you would code that. I'm not quite sure what to do about that one. So if we just check the circuit schedule here, we can actually just compare what's on here to what's in the board, just to make sure that it is actually accurate. So the first two circuits there, you've got they're 1.5 with a 1mm CPC. You've got smoke detectors and then intruder alarm brackets future. So that looks fine. That does look like 1.5. They're both they've got a B6 and a B10, which is correct. The intruder alarm, presumably that just goes to a blanked off spur that's not doing anything at the moment, so we don't really need to test that. Then we've got induction hob, which is 10mm with a 4mm CPC. That looks about right. Then you've got a kitchen ring main, two 2.5s. Then we've got a washer dryer circuit. Then we've got lights, bedroom, hall and lounge. Looks like they've added something to that later, because it says 1.5 on one, but actually it looks to me like one of these conductors has been added. Oh, it's a flex. Oh, okay, it's probably feeding that contactor or something. Oh no, it's a flex. I don't know where that goes off to actually. But anyway, oh man, it's so hot in here. Lounge, bedroom, towel, ring main. Then we've got an oven circuit, which is just like a radial, 20 amp radial. Then we've got a heat interface unit and manifold, which is a 16 amp radial. And then we've got a 6 amp circuit for the lighting in the kitchen and bathrooms. And obviously there's that contactor that's been added on the end, which I'm not sure what that does, but I'm sure we can figure that out. So what I'm going to do is run round with my long wander lead, just check continuity on everything and make sure that there's nothing glaringly obvious. Then I'll probably do R1 and R2 on the furthest points, insulation resistance across the whole lot, because I'm guessing that the insulation readings will be fairly good. And then I'll do my RCD tests. Shouldn't take too long, this one, hopefully. Let's see. So somebody was asking me the other day, do I do cross connection tests when I do ring circuit testing? And my answer is yes, if at all possible. So in this situation, it should be fairly easy to do. So I'm going to do the end-to-end testing first, which is just basically testing between the various conductors end to end. So line to line, we've got 0.23 ohms. Then neutral to neutral, 0.25. And then CPC to CPC, 0.34, which is perfect. It's exactly what we would expect. But then to do the internet connection test, so I usually use these Wargo connectors, Vargo or Wargo or Wago or whatever you call them. Basically, you've got to figure out which cable's which in order to do it. And in this case, it's not so easy to see. So what I might have to do is do a bit of a guessing game. So if I just connect 2 random ones, like that, and then test the other ends, see what we get. Okay, so we've not got continuity. Oh wait, line's not in properly. Okay, 0.54, which sounds about right, because that would be the R2 reading plus the R1 reading all the way around the circuit. So we had, say, what did I say, like 0.23 and then 0.34 or something. So that gives us like 0.56, so that's about right. We're pretty close. So I think this is the right combination, but what I'll do just to check is if I try it the other way with the other CPC and test that. Okay, we've got exactly the same. Yeah, I suppose that would make sense, wouldn't it? So, does anyone know a good way of doing this without visibly seeing the cable? How can you know that you've got the opposite legs? Because what you're supposed to do then is connect the other side and then test at each socket outlet. Now I can do that and see what reading I come up with. Alright, so interestingly, I've just tested that and I've got a reading of like 4 point something ohms, so very high. So if I now try it this way, we'll see what we come up with. Presumably it was the wrong way round. So there's a serious brain fog going on with me today. I'm just back from holiday. You know that feeling when you're just back from holiday and you really don't want to go back to work? Yeah, the readings are still all over the place. I've got like 0.13 at one socket and then I've got 0.37 at another socket. So it's a little bit all over the place. And because I can't trace to see which cable's which, I can't think today, my brain is not working, how to actually identify if I've got them right or not. It's going to be one of those days today. It's you know, it's 2 o'clock in the afternoon and I'm just basically starting work because I had to spend the morning in the office today just sorting out the paperwork from last week while I was away, sending all the EICRs and invoices out and stuff. So that was my morning kind of gone. And I'm supposed to be doing a consumer unit change and this EICR this afternoon, but somehow I don't think that's going to happen. Anyway, our end-to-ends were good, so that's cool. Cross connection was okay, but it was just, you know, the readings were a little bit different between 2 different sockets. So normally they should be the same, that's the thing. They should basically be the same at every socket because you're testing around the full length of the circuit every time. So that's what I was kind of trying to demonstrate, but I've demonstrated it on other videos, so have a look at some of my other EICR videos if you want to learn about that, or just watch somebody else's videos who's better than me, because somebody like David Savory, he's quite a clever chap. He's certainly cleverer than me when it comes to all this kind of stuff. So that's our ring connected back in. Gonna do the other ring here. Maybe we'll try again with this one and see how this one goes. It's LSF cable, this, so it's quite stiff. So what have we got here for end-to-end line conductors? Oh great, I've got no end to end. Makes no sense. Great. No end to end on any of these, so I'm going to have to check the circuit schedule and make sure I'm not going mad, but I'm pretty sure this is supposed to be a ring. Yes, ring main. Circuit 9. 1, 2. Yeah, that is that one. Why the heck is there no ring there? That's ridiculous. It's a brand new build. This makes no sense. So this is the ring main that does the everything else, basically, apart from the kitchen, lounge, bedroom, hall, and towel rail. So, what do you do now? Do you downgrade it to a 20 amp, and then it's done, and it's safe? Ah, wait, I'm being stupid. Oh my goodness. Right, this is what I mean. I had my stupid plug-in lead plugged in, didn't I? Not my normal clip-on leads. So now, thank goodness for that. This is the danger of working in the heat, I think, because you just get brain fog and then start to do stupid things. Okay, zeroed my leads, let's start again. Yeah, it doesn't make any sense for it to be a broken ring on a new build. Well, it's not new, but... Okay, we've got 0.57 on that. 0.7 on the neutral. 0.57, sorry. And 0.93 on the CPC, which is great. And let's just do the same on this. Pick a random conductor, and then with my plug-in tester I'll just check a few of the sockets. Yeah, so they're all about the same, about 0.3, so that's fine. One interesting thing is that it's quite amazing to see the resistance variance in the switches. Like, if you measure one side of the socket and then the other side, you do get quite a bit of resistance sometimes just through the switch in the socket, which is quite surprising, really. Oh, I'm so tired. I didn't sleep very well last night because it was so hot, and my sleep pattern is just out because I've been staying up till 1 o'clock in the morning out in Paris. And I am just not feeling it today at all. And as you know, because you see me quite regularly on these videos, that's quite rare for me. I'm usually quite a chirpy chap, really. But today is just not my day. So there you go. I am human too. Now obviously, you know, it's a plastic board, so straight away that's a C2. No. So, plastic board, some people would put it as a C3. Some people would just put a note to say that, you know, it doesn't comply with the 18th edition. There's no there's no SPD either. So obviously that's, you know, C1. No, I'm joking. You know, as SPD usually, a lack of SPD usually I put as a C3. Plastic board I put as a C3 as well usually, but I know that some people will tell me that's like, you know, being a complete heathen if you do that. So I'll leave you guys to debate in the comments. I know that you like to argue amongst yourselves at times. At the end of the day, it's down to each person's engineering judgment, who's doing EICRs, to choose how they code things. And we do code to the 18th edition, but obviously just because it doesn't comply with the current regulations doesn't mean that it's not safe. It just doesn't comply with the current standard, that's all. Doesn't mean it's not safe. You know, I can't say that because there's no SPD here it's an unsafe installation, or that it's because it's a plastic board it's an unsafe installation, because as long as there's no signs of overheating or anything, you know, no loose connections, plastic board's not been a problem for the last 8 years. Why would it be anymore, you know? So one of the things on the EICR report is to check the tightness of all the connections. So that's something that we do have to do, and it's more, you know, it's not a case of tightening them up really, it's just to make sure that there's no loose connections. So some people say, oh, you should be using a Torx screwdriver. Well, not really, because all I'm checking is to make sure that there's no loose connections. I'm not cranking them all up or anything. I'm just literally checking to make sure that none of them are loose, because I have come across installations where there have been loose connections, just like a screw that was never tightened up basically, and that can be a real problem. So those are all fine, all okie doke on the bottom as well. So I'm just gonna jump off this video now because I think the rest of it is fairly self-explanatory. If I find any other craziness, I will let you know. Otherwise, thanks for watching as always. And if you haven't done so already, subscribe, hit the notification bell, turn the like button blue, and go and watch some of my other videos, because this is definitely not the most entertaining one. But I hope you've enjoyed seeing me suffering, sweating and yawning, and see you on the next one. Thanks for watching and have a great day.